Hello friends and welcome to another tutorial on Geeks4Geeks. In this video, we are going to understand the program which checks whether a given binary tree is a perfect binary tree or not. First, let us take an example. A binary tree is a perfect binary tree in which all the internal nodes have two children and all leaves are at same level. Now, let us see the algorithm which will assist us in checking whether a given binary tree is perfect or not. Let us also have a sample tree to test our algorithm. First, we find the depth of the deepest leaf node in this binary tree, which is 3. We assume that the function for finding the depth is already made and returns the value to d in function is perfect. So, d will be equal to 3. We call the isPerfectREC function with d and root passed as parameter, and we take a level variable which we initialize to 0. Since root is not null, we check if root is a leaf node. As node 1 has both left and right children, it is not a leaf node, and now we check if one of the child is null. As it is again false, we recursively call for the left and right subtree. So first we pass the left child of 1, which is 2, along with level plus 1. Again, as root is not null and it is not a leaf node and both children are not empty, we call for the left child of 2, which is 4, along with level plus 1. Now, as root is a leaf node, we return true as d is equal to level plus 1. Next, we pass the right child of 2, which is 5, so root will point to 5. As 5 is a leaf node, we return true because d is equal to level plus 1. True ANDed with true will return true. Execution for node 1 is resumed and now we pass the right child of 1, which is 3. So root will point to 3. Since root is not null, we check if it is a leaf node. As it is not, we further check if any of the children is null. Since it is not, we call for the left and right child of root. So first we pass the left child of 3, which is 6. As root is but 6 is a leaf node, we return true because d is equal to level plus 1. Next, we pass the right child of 3, which is 7. So root will point to 7. As 7 is a leaf node, we check if d is equal to level plus 1. And as it is true, we return true. True ANDed with true will return true and we finish execution for node 3. Finally, true ANDed with true will return true to the caller function and hence this is a perfect binary tree. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity, where n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.